Okay, so chapter one of getting started on Hopper to eventually end up making a scale using a load cell. Let's get started. Um, so we'll start with the releases on the GitHub repo of Hopper, and there'll be a link in the description of this video to the latest release. So you go to the latest release, and then you're going to want to download this zip file. So click on that to download. Now, I'm getting a certificate to sign the executable, but until then we might get a little warning. And then the other thing we want to download is the UF2 file that we're going to flash onto our microcontroller. And we've got a Pi Pico W, so we're going to download that one. Yeah. So I've got two downloads. Let me put them both on my desktop. There they are. Did I just do the same one twice? There's the other one. There we go. Both on my desktop. I can hide that away now. So I'm just going to unzip this one straight to my desktop. You can put it anywhere, but I'm just popping it on my desktop for convenience. But you can put it anywhere on your computer, your Windows computer. Right, it's going to take a little while to download. And then after I've shown you how to install and get Hopper up and running, I'll show you how to put this firmware onto your device. Right, so I can delete the zip file now. We're done with it. And I can open this. And in the bin folder, there's going to be, if you sort by type, it puts the executable at the top. And it might give me a warning the first time I try and run this because it's not assigned executable yet. It will be soon. So yes, this one here. So you can just say, if you're still getting this warning, you can just say more info and run anyway. Since we know it came from my GitHub, it's probably fine. I don't know why that gave us a weird screen. Let's see what happens. Oh, got this weird ghosting here. Let's run again. It only gives you that warning once. There we go. So that's how you get the Hopper environment up and running. Right. So next part, let me show the device. So let's have a look at this. So if you take a closer look at your Raspberry Pi, don't worry about the red wires for now. Just this little button here is the boot select button. So what I do is this plug is connected to my computer, serial micro USB. So I hold down the boot select button and I plug this plug in while the button is down, and then I release it, and then you can hear the USB. Now, if this is the first time you're doing it, you should let it wait a little while so that Windows can identify what that is and set it up properly. But once it's set up, now if we switch back to the other view, you can see here there's a folder that's appeared. On my machine, it's drive F, RPI, RP2, right? So that's just appeared is a USB sort of version of the microcontroller. It's appeared on my so there it is. It's got this info UFT, etc. And this is our UF2 file that's on our desktop. And all we do is we pick that up and we drop it in here like that. And that is how you get the Hopper firmware onto your Pi Pico W. Right. Now let's go back to this again. So now we've got Hopper on the device. And if we go, and this is the Hopper shell. It's not your Windows shell. It's the Hopper shell. So if we go, I know there's under source, there's a samples MCU. So CD space source / sample / MCU microcontroller unit. And I can go edit blink. And change my board here to a Pico W. So edit, like I did there, Blink appeared because it was already there, and it's blink.hs, which it was defaults to, but there was already a Blink file in this folder. So if I do a dir, here there's a Blink file. If it didn't exist already, it would have prompted you to create it, but I already have a Blink program there. I say use my board, and if you look under the boards folder, you can see the different boards. So if I go into this Hopper folder here under source, library, boards, these are all the boards supported by Hopper, and there's Pico W, right? Okay, if we look inside there, it'll say there's a built-in LED and it knows where it is. So that means that I can use the special functions to just blink the built-in LED, right? So all the menu options are on these, all the keyboard shortcuts are over here. So I'm going to build it with F7. I'm going to say save on build like that. So if I make changes, it's automatically going to save before it builds. Otherwise, it'll prompt me, do you want to save the changes before you build? And the rest of the options are pretty much the way you want them. So F7 to build. If you look at the bottom of the screen, pre-processing, compiling, optimizing, generating code, etc. And now these next two options are no longer grayed. They are now available to me. So with F5, I can launch the debugger, or I can click here and it'll launch the debugger. And if you look at the bottom of the top of the screen, it changed from blue to green. That means we're in the debugger now, not the editor. We can't edit here. And the bottom of the screen successfully uploaded blink.exe. And then over here, I can just press F5 to start with debugging. So if I press F5 here, running in the debugger, and this means I've been talking for 2.5 minutes. That's how long the power's been on, because it's seconds since the power went on. And then you can see we've got a blinking LED. And this time in seconds here is how long it has been since we powered up the device. All right. So that's how you get from 0 to blink in terms of downloading and installing it on your microcontroller. So now let's talk a little bit about the wiring over here, because we're going to do something different next. So let's expand that. Right. So how does this wiring work? Why do I know which pins are which, right? So if you, let's switch to that. If you Google Pi Pico W pinout, you get all these options for showing you which pins are which. The one I like the most is Renzo's. He's really nice at documenting things. So this is Renzo's one. Unfortunately, on these boards, the pins aren't labeled on the top of the board very well. They're on the underside of the board, which is nuts. But with this, you can figure out which pins are which. So we can see there's lots of ground pins. There's only one, and you can see the arrow means output. In other words, 3.5 volts that I can use. And then the other ones that are going to be interesting to us right now are the GPIO pins. So general purpose input-output pins, right? And we're gonna use pin 14 and 15, these two down here. So make a mental note of where these are. So we've got a ground on pin 3. We got 3 volts on pin 5. So let's see what we do with that. So we have a ground on pin 3, and I've conveniently put it in the in the breadboard so that the pins are counting from 1 on the right. So pin 3 here from the top is a ground, and pin 5 from the top, which is actually pin 36, but it's 5 from the top, is the positive 3.5 volts. And then one thing I do on almost all my breadboard layouts is I just connect those two rails across. Important to put them the right way around, don't short it out. So black to black, red to red, right? So now we've got some power rails. And then another thing I like to do is with LEDs, if you just plug the LED straight into the output port, it's going to draw way too much current. and possibly damage either the LED or your microcontroller. So I solder inline on it a 470 ohm resistor, and I always put it on the negative side of the LED. So more than you ever needed to know about LEDs. The LEDs typically, the longer lead is the negative, which is the cathode, and the shorter lead is the anode, which is positive, I believe, normally. And the flat side of the LED, it's got a little flat edge on it, is also the negative. So I chop that off and I put on a 470 ohm resistor on that side. And then what we're going to do with them is we're going to put them between the between ground and our two pins that we wanted to play with. So I think they were 15 or 16. So there's like one of them across to that bottom pin, and another one to the next pin up. And I don't know what they're just going to. One's just sort of semi-on glowing right now. But there we got from ground to our bottom two pins. So switching back to see what that means again. So that's 15 and 14, right? I just paused the video because I was doubting myself. I tend to flip things around in my head. And I just got one that's unmodified to check which is which. And the flat is on top there. So that's the cathode, which is negative, and that's the shorter lead. So the shorter lead is the negative side, which is the one you clip off and put your resistor in line. So you put your current limiting resistor on the shorter lead, and that's the one that's going to go to ground. Right. Okay. Now let's write a program to blink those two LEDs instead of the default ones. Okay, so we'll Control C to stop the debugger, Alt F4 to exit the debugger, and then I'm just going to copy a bit of this so I don't have to do it again. And I'm going to go edit blink GPIO.hopper. So I'm making a new file now. So it'll say, do you want to make a new file? Yes. Just going to paste that in. And you can, the main part of a Hopper program, you typically do like that. And there's a bug in this editor that the syntax highlighting isn't working the first time around, but if I edit it again, the syntax highlighting is working. Okay. So I'm using my same board. You've got to put a board in to use a board. Like you've got to say, I want to use a board. And then to use GPIO pins, you need to, like Arduino, you need to tell the microcontroller that they are output pins. And then after that, you can start blinking them. So to tell them they're output pins, there's an instruction called pin mode, a method called pin mode like that. If I just build this quickly, so I comment that out, and F7 to build. Yeah, I forgot to say save. So I'm just going to go change that option to say save when I make changes before I build. Otherwise, it prompts you every time you make a change. Are you sure you want to save it? Now that I've built it, I should be able to right-click on pin mode. And it takes me to the definition of pin mode. So now I can see pin mode has a pin and a pin mode option. And the pin mode option is going to be output. Right. And then control backspace jumps back to where I was. There we go. So pin mode, and the pin we wanted was, I said GPIO 15 and 14. So let's just verify that. So yes, 14 and 15 are the ones we want. Right, so GP 14 and pin mode output. Oops, it's got undo and redo, etc. This editor is pretty much what you expect an editor to be. So undo and redo, all these shortcut keys are on the menu. Right, so I've set my two pins to be output pins, and now we've got in something like C or Java, you'd go while true and do a loop. And you do that so often that Hopper just has something called loop. Right, so now we can do digital write. Also, it's very similar to Arduino. Digital write, and first let's do that pin number, and let's set that one to false, which is like low in Arduino, and we can set the other one to true. And then we can delay for half a second, which is 500 milliseconds. And then we'll switch them to the other way around, true, false. So this is the longhand way of doing a blink program, as opposed to the one you saw the first time around, which was using the built-in LED, which has some built-in smarts that makes it easy to use, because you use a built-in LED quite a lot for things like diagnostics, so it's nice to have. So I F7 that again, so it built it all. If there was an error, like a syntax error, let's take away a semicolon and try building again. And let's assume my cursor was somewhere else in the program. It's up here on the hopper. There's an error on the bottom line here, and it says there's a semicolon expected. And if I double click on the error, it'll take me to where it was expected. So it was expecting the semicolon before delay. So if I go back before delay, there's the semicolon. So there's lots of things you can click on. You can click on the file names up here. You can click on the paths. You can right click on functions and properties. So I can right click on this pin mode and it'll take me to all the other pin mode definitions, etc. So it's very easy to navigate around this. And the way I keep jumping back to where I was is just control backspace takes me back to where the place I jumped from most recently. And it's a stack, so it can do multiple versions, multiple depth. Okay, F5 to load that. So that's this again. Launch debugger is F5. So successfully uploaded blink GPIO.ihex. And now we can F5 and run it in the debugger. And there we go. Our little LEDs are alternating as we expect them to, based on what the program was doing. And we might as well intro as part of this how we use the debugger. So when I've got the green bar up here and I'm running in the debugger as per the bottom line here, I can press Control C to break. And now it says break. There's the stack trace. I'm waiting in the debugger. And we've got options here to step. So we've got step over and step into. All of these are system methods, so it's just going to step over all of them anyway. So F10 or F11, it's not going to make any difference in this mode. So I can step through this. And if you pay attention to this as I'm stepping, it makes sense as to how the LEDs are changing as I'm stepping. And then another thing I can do is I can put a breakpoint here. So I click on that line up there and press F9. It turns pink. It's got a little red dot in the left there to show it's a breakpoint. I F5 to the breakpoint. So now it's gray, it's sitting on that line. And if I press F5 again, it's going to take a second to get back around there again. It's going to blink both lights on the way. There we go. So every time I press F5, it wraps around to there again. And when it's running, it turns pink. And when it stops there again, it turns gray. So that's how breakpoints work. All right. That's quite a lot to work through. But it's a good short sample to like start from nothing and end up with your own Blink GPIO sample. Because once you've done this, you'll get that, and you can see in the right here, there's just barely visible. There's one line showing me a variable, and that's a global variable. But that's the watch area for the debugger, the watch window, and this here is the serial port. So let's do one more thing. So we can do, let's exit back out. And let's just put a dot here maybe. So we can just say write a dot. And there might be more than one write. So this might be ambiguous. It might not know what that write is. Oh no, it looks like there's only one write. So this write is in a unit called IO. So if I go to that unit, I right-clicked on it, there's a write and a write hex and a write lin and all that. And this is in the unit called IO. So control backspace, I can actually qualify it by putting IO, right? And because there's only one digital write in the universe, it doesn't need to be qualified. It knows I mean the digital write that's in the microcontroller unit. But sometimes you end up with ambiguous things like, everybody puts initialize or create or something in their unit. So I can actually qualify all these MCU methods with MCU dot. And time is not, so delay is from the time unit, which is over here. And these are the other things you can do in delay. In time. So, I can put time in there to qualify that. So that's the same program. Let's run it again. We should get a dot on every lap now. We should get a dot in the serial output, which is that black and green area. So F5, run in the debugger. It's launched in the debugger. F5 again to run it in the debugger. So every time we flash now, once per second here, we're getting a dot up here, right? All right. One more thing. I can run without the debugger just by going Control F5, and then the debugger runs slower, and sometimes you want to see the whole serial view. So Control F5 will just run it like this in the console. But you can Control C to get out of there again as well. Yeah, and one of the reasons, if you want to see the whole screen, for example, so let's just do this as Pico W. The example of why you might want to just Control F5 rather than F5. It's another sample. All the source code is in that zip file you unzipped, so all these samples are all there, just in the source tree. And there's tons of other videos. Okay, so it didn't stop after it ran, so I could make it wait for a little. Over here, delay for 3 seconds at the end. Yeah, this is that option to say save. I should have clicked. Yes, it's annoying to be prompted to save every time you make a change in build. So that's why you'd go and set this save on build option. So now it's set. Right, so Control F5. Now we should wait for about 3 seconds at the end of our Mandelbrot. So we're waiting 3 seconds and then going. And for this, it's nice to not, like if you did that in the debugger, it wouldn't look as good, would it? Right. Anyway, so that's why we have run with it and run without the debugger. All right, I think that's plenty for one demo. So I'll leave you on that. And our next we're going to move on to why units are the way they are and how we create a unit and how the drivers work. And the one we're going to use in particular is the HX711, which is the little controller. It's the little controller chip we use for our load cells. So where's one? I've got one over here. So one of these. So from SparkFun. So load cell amplifier. So we'll work on this in the next chapter. Thank you for watching.